Good morning, everyone, and welcome back to Data Structures Theory Sessions. Last week, we were continuing with the delete operations on singly linked list. And in the last week, we had seen delete last, delete at position, and delete before also. Now let's continue and have a look at the remaining delete operations today. And we actually want to start with delete after, right? So deleting a node in a linked list is first we need to find out that node. So we had a address of that node, and once we found that node, we can call free function, or we can make that memory free. That's how we delete a node. But when we delete a node from any place, we need to be sure about maintaining the pointers, previous node pointer, and so on, right? That's the delete operation. And the next operation that we want to have a look at is delete after. As always, we have our start pointer, which is pointing to the start node, first node, and user will give you the value, existing value. So first you need to search this value, and you need to have that node. And once you have that node, you will be able to delete it. Now, if your linked list is empty, so if your start is pointing to null, there is nothing to delete, linked list is empty kind of message you can give. But if your linked list is not empty, then again, there are a few possibilities. If your existing value eval is there in the first node, then you will be performing delete first. So that is kind of case one, we can say. Start points to data is equals to existing value. Then this is nothing but the delete first. And we have already seen this process, right? Now, what if your first node does not have existing value given? Then we traverse our linked list and we search that existing value. So that's the case two that we want to have a look at right now here, right? So in that case, second case, let's say we have our start pointing to a node, and continuously we have some nodes here. Oh, sorry, this is my mistake. Case one is, look, we are looking at delete after. So if start points to data is existing value, then it is not delete first, it is actually delete second, and that's not the case. But this is in delete after, there won't be any case of having delete first or where your start will be updated. Okay, delete after is a process where you will never update your start. So here we need to have a look at only one case. We need to search a value, and whatever node after that value, we are going to delete it. So let's say we have these values. We have 2, 4, 6, and 8. And if user gives existing value to be 4, then we actually need to search this 4 anywhere in our linked list, right? And once we found it, we actually want to delete a node which is after that value. So we actually want to delete 6 here. That's what we want to perform here in delete after. So we know how to find a value, search a value in a linked list. So let's go and traverse our linked list to find that value. So we need tr starting from the first node, and then we'll go for a loop where continuously we are going to update our tr with next node, right? Now when we are going for searching a value, we actually search a data. Tr points to data, right? While your data is not equals to the given value, you will go further. You will go to next node. So while tr points to data is not equals to existing value, we are going to run this loop and tr will be going to the next node. Now tr points to data we can only have if our tr itself is not null. Right? Your tr must be not null. If tr becomes null, then we can say we are done with the entire linked list and still we don't found that value. So we can say if your tr becomes null, then value not found. Else you found that value. So when you go through this process, you start your tr with the first node and you compare this value 2 with existing value 4. 2 is not equals to 4, so we'll update our tr. And then again we repeat the process. Tr points to data 4 is equals to existing value 4. Yes, we found it. We stop here. Now when we stop, our tr is pointing to the node which is having that existing value. Now what we want to do is we want to delete the next node. So from tr, have a look at now in this process. From tr, we can find its next node, and that is what we want to delete. So we are going to find the next node from tr points to next. So now we can have del here, right? We found this del node, and once we have it, we can make it free. We can delete that node del. But before we delete, don't forget to update your pointers. Now if you delete this node 6, then its previous node next pointer should be updated. It should point to the next node now. So what is that pointer? Tr points to next. So we need to update tr points to next. And we actually want to have the address of node 8. Now from where we can have address of that node? We can have that address from this deleting node next pointer. So before we delete that node, we are going to have del points to next. Del points to next. That's how we can have the address of 8. So we are going to store that address of 8 in the next pointer of 4. And that's all. That's it. That's how you delete your node which is after the given value. So you traverse your linked list first. Okay. You find that value. Once you have it, you take the next node. Now here we can have two possibilities. What if user has already given you 8 as an existing value? Then you will find that value at the end, and there is nothing after that last node. So that can be your additional case, and that case you can handle here at this else. You can have else if later here, if tr points to next is already null, then you can give a message delete node does not exist. Otherwise, you can go and delete that process. Right? So that can be two different cases here. Let's have a look at the algorithm for this one. And algorithm covers every possibilities here. So if your start is null, then underflow. Otherwise, we need to traverse. So we take ptr, temporary variable. And later on, we will need del temporary variable also. So we have it here. Now what we do here is we are going to traverse our linked list. till your PTR points to data is not equals to existing value. And at the same time, PTR should not be null. We update our PTR equals to PTR points to next. Now this is simply the traversal process up to that value. Once we terminate this loop, we are going to have different possibilities. If PTR is null, then you can say value not found. If PTR next is null, then we can say delete node does not exist, because your PTR is at a last node and there is nothing after that. Okay, so that's the second one. And if you do have something after the current node, then you take that next node in DEL so that you can make it free. But before we make it free, we update PTR points to next equals to del points to next. And we simply exit here. We do not have return start here because there is no possibility where we return we actually update our start. So this is delete after. Go and read this entire process once, and I'll stop talking for a while now, so that you can focus on this and read it. Going to the next slide. So that was the delete after operation. Now next operation we want to have a look at is delete the first occurrence of a given value. Okay, delete first occurrence. Whatever value given to you, you are going to search that value and you will delete that node. The node which is having that value, we want to delete it, and we'll delete the first occurrence only. We are not going to find the other occurrences of the same value. That's what this function is all about. Now here it can be the case which I was talking earlier. So we can have that existing value in the first node. So if your start points to data is actually the existing value, given value, then it is delete first. And the second case is where you need to search that value and you want to delete that node. So let's say if your start is pointing to a node and you have some further nodes, and let's say existing value given to you is 6, then actually we will start searching that node using tr traversal. 2 equals to 6, no, then we'll go further. 4 equals to 6, no, we go further. 6 equals to 6, yes, we'll stop here. So that's how we traverse. tr points to data, we need to compare. Now once we found that node, we are going to delete that node. Then we actually need the previous node also, so that we can update this pointer like this way, which means we need previous node, so we also need pre. Something like this. Now funda of previous node handling we have already seen, so let's have a look at that entire process. We start with the first node, and at that time our pre will be null. Then what we do is we go for a loop and we run our loop with tr equals to tr points to next. But before we update our tr, we take its backup in pre. Now what should be the condition? So we say our tr should not become null, and at the same time your tr points to data is not equals to existing value, then we are going to traverse. So this is the traversal process. Once we are done with this traversal, then we will compare. If tr becomes null, then we say value not found. Otherwise, your tr will be pointing to a node which actually you want to delete. So you want to make it free. And before you make it free, make sure that its previous node next pointer we are going to update. We'll update it with the address of 8. अब 8 का एड्रेस कहाँ से मिलेगा? tr के next से. So pre next equals to tr next, and then we can make tr free, and we are done. So this was very simple. Again, let's have a look at this process. User has given us the value, and we want to delete a node which is having that value. So first we'll search that node based on the value comparison data. So tr points to data not equals to given value, then you traverse. After traversal, if your tr becomes null, then value not found. Otherwise, tr will be pointing to the node which you want to delete. Now if we delete that node, then we need to update the previous node next pointer. For that, we also take pre. Once we have it, pre points to next equals to tr points to next, and we are going to delete only one occurrence of that value. So it might be possible later on somewhere you have 6, but we are not bothering of that that node. Whatever node first occurs, we will delete. Right, so that's the delete first occurrence. Let me show you the algorithm. So if your start is null, underflow. Otherwise, we take temporary variables ptr and pre-ptr so that we can traverse. If, as I have said, case 1, if your start data is existing value, then delete first. So if your start data is existing value, then you update your start and you delete the first node, ptr, and you return. Simple. If that is not the case, then we are going to search a node which is having that value. So ptr data is not equals to existing value, we are going to traverse. Alongside, ptr should not be null, and we should also take backup of ptr before we update it. At the end of this while loop or iteration, we check if ptr becomes null, we say value not found. Otherwise, pre-ptr next equals to ptr next and pre your ptr. There was a possibility where we update our start pointer, so we return start. This is the delete first occurrence. Now, deleting a first occurrence is simple. Have a look at this entire process once and read the algorithm also. This is simple, but with having this base, we will be able to delete multiple occurrences later. So go for this process. Have a look at this diagram and understand it. Then I'll show you the algorithm to read. So read this algorithm carefully now and try to simulate that process in your mind. If start data is not equals to existing value, then we go further, we traverse our linked list, search that node, and then delete it. So the remaining part of the algorithm here. Okay, so We looked at delete after and delete first occurrence. If you do have any question in these two operations, please ask. After that, we will see the next operation. If you have any doubt or any question here, you can ask. Okay, let's move on. So that was deleting a first occurrence only. Now, what if you want to delete all the occurrences of a given value? And that's what the next operation is. Delete all occurrence. Now your given value can be at any place. Okay, this given existing value can be at any place in your entire linked list. And we want to find out all those places, and we want to delete those nodes. Right? So it might be possible that your first node has the same value, given value. Then you delete your first node. Now, as long as we want to delete all the occurrences, it is also possible that this given value will be at a second node also. Then we will delete first node, we will delete second node. If that value is at the third node, then also we need to delete it. So delete a third node. So this is a case where we are having this existing value starting from the first node, and we have multiple nodes at a starting place. We found those values. So it is something like this. Start is pointing to a node, and iteratively some of your initial nodes contains that value. For example, let's say user wants to delete all the occurrences of value 2, and you have 2 at a first node, 2 at a second node, 2 at a third node, and so on. Now in this case, we actually need to delete all these nodes, all the occurrences of 2. We want to delete all those nodes. And this is the case where actually we are going to update our start also. So this is a special case where we update our start. So delete first, that's not the only possibility here. Delete first will only delete one node, but here we want to delete 3 nodes. Now let's have a look at what was the condition for delete first. It was something like, if your start points to data is equals to the existing value. If this is the case, then what you do is you take backup of start. It can be tr or it can be del. Let us call it del, because that's what we want to delete. We want to delete, sorry, we want to make it free del. So we take backup of first node so that we can make it free. But before we make it free, what we do is we update our start. Start equals to start points to next. This is what we do when our first node is having that value and we want to delete that node. Now this is the if condition, so it is going to run once only. एक ही बार रन होगा। अब हमें क्या करना है, we want to delete it, we want to delete all consecutive nodes while your start data is having existing value. You take backup of your start, you update your start and make it free, right? So for the first time when this loop runs, you will delete this node, first node, and what are you going to do is you will update your start. For the second time, this is your start node now, and that also has the same value. So you will still go in a while loop. You will take backup of second node so that you can make it free. So आप second node भी delete करोगे, and also you will update your start. Now this third node becomes your start node, and again you are going for while loop. Start points to data is existing value. Yes, it is still equal. So you will delete this third node also. And when you delete it, you will update your start, and now your start will be the next node, which is 4. So that's how this process works. Now we do not end up here. This is the only possibility we are looking, where initial nodes has that value. Still, we want to have a look at what if other nodes after this 4 has those values. So it is something where, let's say, start is pointing to some node or something, whatever, but later on within your entire linked list, you have those values. So it is like something, let's say you have 4 at a starting place, but later on somewhere you have further nodes having those values. Now in this case, what we want to do is we want to delete this as well as this. Now we have taken care of initial nodes having same value. So using this while loop, we have considered that process. That's okay. But once your start node reaches once your starting pointer reaches at a node, and what if after that you have some nodes, then we also need to delete those nodes, and that's what the process we will be looking at now. एक बार initial nodes का process खत्म हो जाता है, which means your start node does not have that value now. Start node में वो value नहीं है. 2 is not there in the starting node. तो अब हमें आगे के nodes check करने हैं. We want to traverse, लेकिन हम ये traversal directly second node से start करेंगे. So we will initialize our TR with start points to next. So my TR will be pointing to the second node. Now if I delete that TR node, then I also need to update previous node next pointer, which means I will need my previous pointer also. So let's have it. We will initialize our pre with the first node. So TR में second node लिया, pre में first node ले लिया. This is how we initialize, and then we will traverse while we are going to traverse. Now when I'm going to traverse, I need to have a look at entire linked list. I need to go up to the end. तो फिर मेरा ये traversal process जो है, it is going to be iterated until your TR becomes null. जब तक TR null नहीं हो जाता, which means जब तक आप end तक नहीं पहुंचते, you are going to do this process. We are going to iterate this one. While I'm iterating, so within this while loop, I need to check if my TR points to data is equals to the given value, then I need to make it pre. मुझे उस tr को डिलीट करना होगा। Okay, now if I make that node free, if I delete this tr here, then the pointer that we need to update is what? Previous node का next pointer हमें update करना पड़ेगा। So we say pre points to next equals to tr points to next. That's what you are gonna do. So हमने ये जो pointer है update कर लिया। We update this pointer. And once we delete our tr node, तो pre तो चलो 4 पे point कर रहा है, लेकिन tr has lost. tr अब कुछ भी नहीं है। Right? Now, if we want to traverse, then how do we traverse? हम actually tr का backup pre में लेते हैं, and then we update our tr equals to tr points to next. That's how we traverse actually. लेकिन अगर मैं वो tr को delete करता हूं तो मैं tr next नहीं जा पाऊंगा। So if I delete, then somewhere here I need to reinitialize my tr. So जो pre है हमारे पास उसी को हम tr में डाल देते हैं। That's why we again initialize our tr with a previous node. अगर tr node delete हो गया तो tr को reinitialize करना पड़ेगा। Previous node से initialize कर दो so that you can find the next node here. अब जैसे ही next node मिल जाता है, you are going to repeat this process. So when you have deleted your tr will be initialized with the previous node, like this way. And then you update your tr to the next node. So this is what happens. Your tr is pointing to 6 and previous node is 4 now because 2 has been deleted. 6 is not equals to the existing value, so we update our tr and we also update our pre. So you come here. Now tr data is existing value, yes. So we are going to delete that thing. अगर मैं उसको delete करता हूँ, then I'm going to update my previous node next pointer with tr next. So that becomes null. It's okay. 6 will be the last node now, right? Your tr will be initialized with the previous node. And then tr becomes tr points to next. So tr आ गया null पे. And when your tr becomes null, you stop this process. So this is the deleting multiple occurrences. तो जो delete का जो process है, हम जो node को free करते हैं, that is within while loop के अंदर रहेगा, उसके बाहर नहीं। अगर वो अंदर है, which means multiple nodes can be deleted. अब तक हमने जितने भी process देखी थी, deleting a node was after while, but here it is within while. Okay? So that's the thing. अब एक बात है कि आप यहाँ पे कैसे बोलोगे कि वैल्यू नॉट फाउंड, अगर वैल्यू पूरी है ही नहीं, कहीं पे भी नहीं है, देन हाउ डू यू गोना से वैल्यू नॉट फाउंड? पॉसिबिलिटी स्टार्टिंग में वैल्यू होने की भी है, पॉसिबिलिटी बीच में भी कहीं वैल्यू हो सकती है। सो अगर if there is if you traverse your entire linked list and you not found that, only in that case you can say value not found. अगर कहीं पे भी वैल्यू मिली तो आप उसको डिलीट कर रहे हो। So for that you can have extra flag here. Initialize that flag with 0, and wherever you found a value, wherever you delete a node, you make your flag equals to 1. So initially मेरा फ्लैग 0 था, अगर मुझे एक बार भी वो वैल्यू मिली तो मैंने फ्लैग 1 कर दिया। मान लो कि यहाँ नहीं मिली ओके, आगे जाके if I found that value here, I'll make my flag equals to 1. अगर यहाँ पे भी नहीं मिली, then after I complete my entire process, I can check my flag. If flag is 0, then I can say value not found. That's it. अगर flag कहीं ना कहीं 1 हुआ है, then I'll not print this message. So that's how I can use my flag to identify whether I have that value once, at least once, then no message. Otherwise, at the end, I'll say value not found. So this is delete all occurrence, and this is somewhat complex one. Let me explain this one more time. And if you have missed anything, please be attentive here. When we want to delete multiple occurrences, अगर मुझे एक से ज़्यादा occurrences लिंक लिस्ट में से डिलीट करने हैं, तो मैं पहले एक नोड डिलीट करके रुक नहीं सकता. मुझे कंटिन्यूअसली नेक्स्ट नोड नेक्स्ट नोड नेक्स्ट नोड हर एक नोड को चेक करना पड़ेगा. अब अगर फर्स्ट नोड में ही वो वैल्यू है तो मैं फर्स्ट नोड डिलीट करता हूं, और अगर फर्स्ट नोड डिलीट करता हूं तो मुझे स्टार्ट अपडेट करने की ज़रूरत पड़ेगी. तो उसको हम अलग while लूप से हैंडल करते हैं. While your start data is having existing value, then you update your start. So start को अपडेट करने से पहले existing start जो है उसका बैकअप ले लो, बिकॉज उसको आप डिलीट करने वाले हो. So delete equals to start, then start को अपडेट करो, start equals to start points to next, and make your del free. अब consecutive starting के ही नोड वो वैल्यू नोड में वो वैल्यू हो सकती है. सो वी विल रिपीट दिस एंटायर प्रोसेस. जब ये प्रोसेस खत्म होगा तो स्टार्ट कोई एक नोड पे अटक जाएगा जिसमें वो वैल्यू नहीं है. you'll stop somewhere where it will be the first node and it does not have that existing value. अगर वो उस नोड में अगर ये वैल्यू नहीं है तो आप इस वैल्यू को अब सेकंड नोड से ढूंढना स्टार्ट करोगे. एंड दैट्स व्हाई वी गो फॉर द फर्दर प्रोसेस. टीआर को हमने सेकंड नोड से इनिशियलाइज किया, तो फिर प्रीवियस नोड फर्स्ट नोड हो जाएगा. सो प्री इक्वल्स टू स्टार्ट, एंड देन I'm going to search that value in the entire linked list. तो फिर मेरा while loop जो है वो चलेगा while tr is not equals to null. जब तक tr null नहीं होता, we are going to repeat this entire process. Within that process we will check कि भाई tr का डेटा given value है, अगर है तो उसको डिलीट करना है. अगर मैं उसको डिलीट करूंगा तो उसके प्रीवियस नोड के नेक्स्ट पॉइंटर को अपडेट करना होगा. सो प्री नेक्स्ट इक्वल्स टू tr नेक्स्ट, देन आई कैन मेक tr फ्री. अगर tr को फ्री कर दिया, वो मेमोरी ही फ्री कर दी मैंने, तो मेरा tr कुछ है ही नहीं. इन दैट केस मुझे tr को री इनिशियलाइज करना पड़ेगा, एंड इन दैट केस मैं tr को वन स्टेप बैक ले लूंगा जो प्री है. तो tr को मैंने प्री से इनिशियलाइज कर दिया, सो दैट in a further process I can jump to the next node. tr equals to tr points to next, and repeat the same process. जब tr null हो जाएगा, you will stop your entire process. Now during this entire thing, आपको कैसे पता चलेगा कि वो वैल्यू मिली या नहीं मिली? तो जब भी वैल्यू मिलती है, आप क्या करने जाते हो? you are going to wave your flag. अब फ्लैग क्या है? It is nothing but just a signal. So when I say flag equals to 0, okay, I'm not waving that flag here. But when I found that value, I'll set my flag equals to 1. So using that flag at the end, I can make a decision whether I found that value or I don't found that value. Now, how many times you found that value, अगर वो आपको चाहिए तो आप एक एक्स्ट्रा काउंटर भी ले सकते हो. जब कभी भी आप फ्री करते हो मेमोरी, you increase your counter, तो number of occurrences भी मिल जाएंगे. So that's the process of deleting multiple occurrences. Let's go through the algorithm here. So if your start is already null, you say your linked list is empty. Otherwise, what you do is you start with your flag equals to 0, and you go for the first possibility where consecutively start points to data can be existing value, and your start does not become null. Till that time, you are going to take backup of start so that you can update your start and make it free. If you are making it free, then you also set your flag. Now, this is the first possibility that we have seen. Now, from this process, we are not returning. यहाँ पे कोई go to statement नहीं है, return statement नहीं है, because we want to go for the further process also. After completing this part, we initialize our TR with the second node, pre with the first node, and then we will traverse our further linked list. We are going to traverse it until your PTR becomes null. Within your while loop, you are going to check PTR points to data. If it is existing value, then you update your previous node next pointer and you delete that PTR. अब PTR डिलीट हो गया तो फिर मुझे उसको री इनिशियलाइज करना पड़ेगा. प्रीवियस से री इनिशियलाइज करो and set your flag also. After this if part, you go for the while loop. So PTR का backup and PTR updated. Up to 13, it is while loop. Step number 13, it is while loop. Once you complete your while loop, आप लास्ट में चेक करोगे, अगर अभी भी आपका फ्लैग 0 है तो आप बोल सकते हो वैल्यू नॉट फाउंड. लेकिन अगर एक बार भी वैल्यू आपको मिली होगी तो आपने उसको डिलीट किया होगा. अगर आपने उसको डिलीट किया होगा तो आपने फ्लैग 1 भी किया है. Then will not print this message, and at the end we will return start. So this was the delete all occurrence process. Have a look at the algorithm, read it carefully. Moving to the next slide. So that was delete all occurrences. And next, which is actually the last delete operation on a single linked list, we want to have a look at is delete sorted. This operation will be done only if your existing linked list is already in a sorted manner. If your existing linked list have values already in a sorted manner, then whatever value user wants to delete, you search that value. अब कहाँ तक search करोगे? You are not going to till end. जब तक existing मतलब current node का data existing value से कम है, you are going to traverse it. And when you have existing current node data greater than existing value, you will stop. वहीं से आप stop कर दोगे, आगे search नहीं करोगे, because it is already in a sorted manner. तो existing value बाद में नहीं हो सकती, right? Now I'll go through the algorithm directly, but if you just wanna visualize that thing, then we were doing it already. हर बार मैंने sorted linked list का example ही लिया था यहाँ तक. It is kind of 2, 4, and 6. This is already in sorted manner. And if user wants to delete 4, तो आप यहाँ तक ही traverse करोगे. If user wants to, let's say, delete 3, फिर भी आप यहीं तक traverse करोगे. After this 4, you will stop and you will say value not found. Right? So that's what the benefit of having this operation if your linked list is sorted. Remember. So let's understand that thing directly with the algorithm. If your start is null, underflow, otherwise we are going to traverse. So PTR equals to start, pre-PTR equals to null. अब first case, अगर पहले node में ही existing value मिलती है, then if your start data is existing value, then you delete first and return. अगर start node में आपकी value नहीं है, then you will go further. You are going to traverse. When we traverse, we go PTR equals to PTR next and pre-PTR को backup ले लेंगे, PTR का backup ले लेंगे. But this while loop, इस while loop को हम कब तक चलाएंगे? So we say that if PTR points to data is less than existing value, then we are going to traverse, and at the same time PTR should not become null. So this is the traversal process. PTR points to data is less than existing value. अब ये while loop कब terminate होगी? या तो PTR data equals to existing value हो जाए, या तो PTR data greater than existing value हो जाए. There will be two possibilities, and the third one, PTR becomes null. ये तीन possibilities आपके पास रहेगी. Then your while loop will be terminated. So after terminating that while loop, we say PTR should not be null, and at the same time PTR data is equals to existing value. Then we found that value and we want to delete it. So pre-PTR next equals to PTR next. We update our pointer and free PTR. You delete that node. इसके अलावा कुछ भी अगर है, मान लो कि PTR null हो गया, तो भी value not found. PTR points to data greater than existing value हो गई, then also we say value not found and we return. So this is the delete sorted algorithm. Read it once carefully, and if you have any doubt, you can ask in this process. Going to the next slide. So we have seen number of delete operations today on a single linked list. Now this was actually the last delete operation. If we talk completely, then we have seen number of insert operation, we have seen number of delete operation, and we have also seen how to traverse. So that completes a single linked list actually. Next lecture, we are gonna see the circular linked list. Circular, so last will be pointing to first. That's how we make a circle. So we'll understand what circular linked list is, how to manage it, and then we will see some of the operations on circular linked list in a next lecture. Thank you for joining. If you have any doubt, you can ask, or else we are done. So you may leave this meeting now. Thank you.